Now that we've beat microcontrollers to death, hopefully you can see the power of the microprocessor. Now, I want to introduce you to the Arduino. Now, you've probably heard about it, as it has been all the rage, and as should be. But just what is Arduino? Arduino is an open source standard, is what it is. Open source means it is not a proprietary or protected standard. It's made public, and anyone can make their own, add to it, or develop it further. For instance, you can download the printed circuit board plans and make your own. It's a standard in that the design specifies things like the type, position, and spacing of connectors, and what pin does what. This way you can design your own add-on board, mass produce it, and anyone with that Arduino board can use your expansion board as it's compatible and it fits. You were able to see how microcontrollers gave you the ability to rapidly prototype large, complicated circuits by replacing the circuit with a much smaller, simpler circuit and a program. This also gave you the ability to make major changes to the circuit by simply reprogramming it. No hardware changes necessary. Arduino was specifically designed to enable rapid prototyping in like fashion. Now, in your kit, you received an Arduino Uno board. So this board is built to one Arduino standard, the Uno design standard. All of these connectors are spaced exactly the same distance apart on all boards. It has a microcontroller on board, which you can reprogram. Now, I specifically got the older style Arduino boards with the DIP microcontroller so you could see and understand for yourself. Now, we used the PIC microcontroller, which was made by a company called Microchip. This Arduino uses a microcontroller much like the PIC, but it was made by a different company called Atmel. And here's the microcontroller right here. This board uses the ATmega 328P. Now, these boards are getting harder and harder to find. So if you are getting your own parts, or I was just plain unable to get these original Uno boards, you probably got one of these, one of the newer Uno boards, which uses a surface mount microcontroller. You can see right here. I specifically grabbed the older boards with the DIP microcontroller so that, if you wanted, you could pull that microcontroller out of its socket on the Uno board and use it in a breadboard, just like we did with the PICs. Now, it uses different programming commands because it is made by an entirely different company using an entirely different architecture, but it's the same principles of programming as the PIC. It's got a working register, a stack, all that stuff. Quick point I'll mention, each make of microcontroller has its pros and cons. The PIC micros have that bank select feature, which you have to be careful about. You'll forget to select your bank and your program won't work. Now, it's a pain, but that's the way they designed it. The Atmel micros don't have banks like that. However, you remember the PICs only had, I think if you used the extended instruction set, it was like 49 instructions or something like that. The Atmel has over 130. The PIC's A to D converter is typically faster, but the Atmel usually carries out instructions faster. So there's pros and cons with either controller. Like the PIC, you need some way to program the ATmega. With the PIC, we used our PIC adapter to connect the PIC to our computer to program the microcontroller. In the case of the Arduino, that interface is built into the Arduino board. That's what the USB is for. Some Arduino boards, like this Pro Mini Arduino board, which does not have an onboard interface, that's a separate board you buy like this, which plugs in so you can program it from your computer's USB port. Once it's programmed, you can remove the USB interface, and the advantage is that you are left with an incredibly small computer for your robot. So let me take a moment to explain another portion of the circuit which you don't see. It is the bootloader. If you recall, we could program our PIC even when it was built into a circuit. When we applied power to the PIC, it started running the program that was in its flash memory, starting at location 0. Now, if you recall, we had to apply specific voltages to specific pins on the PIC in order to tell it, hey, I'm sending you a new program. Put this new program into your memory banks. Now, while I didn't get into it yet, you can also program the flash memory from the program itself. The program memory is just memory, registers. They can be read and written to just like any other register. The Arduino does not have the circuitry on the board like what is in your Picket that allows us to program the ATmega. It does have the in-circuit serial programming available, just like our PIC, and here's the connector right here. But we need an external programmer just like we did with the PIC. So what the Arduino designers did was kind of ingenious. They replaced the hardware with a program. Now this program is similar to, say, the Windows operating system on your desktop computer, or Linux if that's what you're running. It's a program, but your computer can't run without it. Now they call this firmware because it's sort of a cross between the hardware and software. So effectively, the designers have replaced hardware with software. Now that's exactly what they did with the ATmega. When you first power up your Arduino, there is a program already installed into the first 2K of flash memory in the ATmega. This firmware is called the bootloader. And like the PIC, when you first power up the ATmega, it starts running whatever program is in its flash memory, starting at location 0. So when you power up the chip, it runs this small little program, which first listens to the USB port to see if there's any communication coming from the Arduino program on your desktop computer. If there is no communication, then after a short delay, it begins running whatever program is stored in the program memory area, starting at memory location 2001. So your instructions aren't installed in the flash memory starting at the first memory location, but rather at a different location. The first 2000 memory locations are reserved for this firmware bootloader, which never gets deleted. If the bootloader starts up and detects communication on the USB port, then it will respond to the USB, to the communication. Now that communication could be your Arduino software on your computer sending a new program. And the bootloader will respond by deleting the previous program already in flash to memory, and will then flash the memory with the new program, storing it in the block of memory designated for your Arduino programs. The advantage being that there is no hardware required on the already crowded board. If you wanted to use all of the memory in the ATmega, because you've got this, massive program that you've written, you can delete the bootloader and use that memory space as well. However, you would then need an external hardware programmer, just like we did with the Picket 3. So also, if you have a programmer for the ATmega, you can pull the chip right off the board and program the ATmega exactly like you did with the PIC. Now, normally, when you buy an Arduino, the bootloader is already installed on the microcontroller. However, if you wanted to update to a new bootloader, or you deleted yours and now you want to put it back on, you need to do that with an external programmer. For the purposes of this course, we will be programming our Arduinos strictly using the bootloader because it allows you to quickly and easily reprogram your ATmega via the USB port built into the board. The bootloader comes pre-installed on the Arduino, and you'll notice that you can actually buy ATmega microcontrollers off of eBay that have been pre-programmed with the Arduino bootloader. So technically, you can slap that chip into your breadboard and you would be running an Arduino. Or if you are making your own Arduino from scratch, you can flash your microcontroller with the bootloader, which you can get off of the Arduino website, and use another Arduino as the programmer. I'll show you how to do that in a later lesson. Now, there's another major aspect to the Arduino standard. While you can program the microcontroller directly, the Arduino developers wanted to simplify the machine code programming. So they developed a programming language. The hope was to make a simpler programming language than machine code. So here's how this works. You write your program in the Arduino language just as a text file. You then run that through a compiler, which converts your code into machine code. It translates your program into the ATmega machine code. The programming language we'll be using is based in the C programming language. That's the letter C. There actually is a C compiler available for the PIC as well, but it's not free and open source like the Arduino compiler. So holding to the theme of rapid prototyping, which involves continual change, they call your Arduino program a sketch. It's a rough drawing that is continually changing. Once you've compiled your program, the Arduino software then downloads the machine code program to the ATmega microcontroller chip through the USB programmer built into the Arduino Uno board. The board has a crystal to lock the clock at a precise frequency, and actually I believe the ATmega microcontroller requires an external crystal, unlike most of the new PIC microcontrollers. Some of the older PICs required an external crystal, or at least an external clock. It's just the way the microcontrollers were designed. And in this case, because they were being added to an actual circuit board, the crystal was just included on the board. The board has the USB interface. It has a power connector with an onboard voltage regulator. So you can source 6 to 20 volts into this connector, and it will regulate it down into 5 and 3.3 volts on the board. They recommend 7 to 12 volts, but it can tolerate as low as 6 volts and as high as 20 volts. It has these sockets which are connected to the various pins on the microcontroller. These ones are connected to the analog pins, and these ones are connected to the digital input-output pins. These ones here you can supply or extract 5 or 3.3 volts. Now, because all these sockets follow a standard, anybody can make a board that mounts on here and it'll fit. These interface boards are called shields, and in your kit you've got one nice shield, which is that full color screen, and you can see it just plugs right in. In your kit, you also got a proto board specifically designed to interface with the Uno board. And we're going to have fun with a project there, designing our own shield. The board also has an LED on it, which we're going to use right off the bat. Now, there are multiple kinds of Arduino boards which have different features. The Arduino Nano and Pro Mini is incredibly compact. One reason is because they ditched the USB interface. So you buy the USB interface separately and use that to program all of your Nano or Pro Mini boards. The Arduino Mega has a whole pile of extra inputs and outputs. The LilyPad was specifically designed to be sewn to costumes and clothing, and in fact the designers thought this through to include sewing with conductive thread. wires, or make connections using snaps like we did with our muscle sensors in the analog electronics module. So now that we have a handle on what Arduino is, let's go right to programming this bad boy.